is, so I have already talked about that. So this is the structure of the OLED is normally. So we just connect to anode, which is that ITO electrode, EM metal. It could be any metal, is probably aluminium mainly we used. We just talk about aluminium, then later we will see what are the different metal can be used as cathode or the metal, the other electrode. So this ITO is transparent one, but here if we use aluminium, it's not transparent. So that we can see the light through this ITO side. So when we connect this cell here, it's a positive side is connected with ITO, and the negative side connected to this metal. So the positive side is release the holes. The holes move from. So why we use a HIL? Actually, HIL is making better contacts with the ITO and the hole transporting layer. That's why we use very thin layer, or less than 10 nanometer. We use normally to make good contact between these two this electrode and this hole transporting layer. So that holes we used to be photons. We say this now is the holes. We talk about these holes. Holes move from here in the HOMO level, and here that cathode release the electrons. It's connected to negative sides electrons. So this move from this the same way the electron injecting layer we used, making the good contact between electron transporting layer and the metal. So it's that electrons move in the LUMO side. So when they reach the right place, the holes and electrons and moves in the emissive layer, they're going to excite, and they give the color. The color is dependent on the PL of this emissive layer. Okay, we will talk about what quality every material needs, then we will understand more about it here. Okay. Then this is the structure I am already talked about. This normal OLED display has this hole injecting layer, hole transporting layer, emissive layer, electron transporting, electron injector on the top and bottom electrodes, and the substrate. We use the substrate. Substrate can be the glass, because if we want we need to use glass if we use to see the bottom emission. To see that if we use cathode as aluminium, then we can't see the light through aluminium. So aluminium is not transparent material. So this is the actual function I have already talked about. This is in the different way. This in the HOMO moving, and here it's mentioned about aluminium is that's 4 electron volt, and this magnesium silver it become 3.6 electron volts, and lithium aluminum, if we use lithium fluoride as EIL, then it's become minus 3.1. We need to reduce this energy level, because then we can easily to transfer electron to the LUMO. So here ITO has we need a high energy level, because it's going to move the HOMO level. So we need to, when we make some device arrangement, we need to know the all materials, HOMO, LUMOs. Probably this other chemist, I think the previous lectures talk about this HOMO, LUMO. I'm not going to talk about about this HOMO, LUMO. The next one. So this is the time frame. Time frame of the devices. How does it they started with? So they use initially in 1965. They just use some emissive material, and use two anodes and connect the electricity, and they see some lights. Then they put some two layers in 1985. They use some two layers that hole transfer, some improve the light or the performance of that device. They just use the hole transporting layer, and here they use the emissive layer with some electron transporting characteristics. MSC layer, they used it here. Then they become use some multi-layers. They use some HIL, HDL, like ETL. It's a whole blocking layer. Sometimes, the organic material, the whole transporting material have higher hole mobility. So the hole travel faster than the electron travel. So it might pass through here than meet here. So they just, they want to stop that whole move to electron side. I mean, electron transport. They just use whole blocker for the organic light emitting diode. So then they can stop the electrons and a hole meets here to emit in the emissive layer. Then nowadays they use to improve that, because we need more holes and more electrons, then we get more performance of the device. So they just dope with the P-type material with the HDL and N-type with the ETL, and improving the hole mobility and the electron mobility, and make high performance devices, because we need high performance devices for the display and lighting. So this is the different type of devices. So devices we just talk about I'm just talking about organic light emitting diode still. So so substrate, you can see the substrate and anode and cathode. Between that, we know that most of them is organic layer. We can use some inorganic also, but this organic all layers. So here, so if the cathode is not transparent, then we can see the light through the substrate. The substrate should be glass, then substrate and anode should be transparent. Then we can see the light through the bottom. So this is called bottom emitting. And if you see that top emitting one, because the anode or the substrate is substrate, it could be a plastic or some not transparent substrate. Then anode also, you can use the thicker silver. Then you can't see the light through here. Then you need to use some transparent material for cathode. Then you can see the light on the top. This is called top emitting. Here we use some steel. We made some OLED in the steel. Then we use the transparent silver on the top to see the light on the top. This is the glass substrate. We use the light in the bottom, and the top is, here I put it other way around. The bottom, the top one is in the bottom there. That is, we used aluminium as a cathode, so we can't see the light through there. So through this ITO, we see the light, and the ITO in the glass, so we can see the light. The same way, we can use the same option here, but an transparent cathode, if we use, we can see the light both sides. Is the transparent OLED device, we can make it through here, or OLED or QLED device we can make through here. So there is our option is always improving the performance. So we sometimes one unit, we call it a one light emitting unit, or that one electroluminescent unit or one light emitting units, it has one HIL, one HDL like this, one cathode, one anode. So this is sometimes not enough efficiency of the device. So we need to make some tandem, also a stack of devices. So if we use two or more this light emitting units, we use it and we connect with the charge generation layer. The charge generation layers, actually we use the PN junction type of material, two type of material. We can easily to connect these devices. Then we can get high performance, high bright, high efficient device. We can make it. And also if we use the three different colors, red, green, blue, or the blue, green, red, or any order, we will get a white color. When we look at it from outside, it become a white device. This concept we use for making white OLED device for the lighting purpose. And also we can use the same color, same pixelized color to improve the performance. So what is that advantage of this? actually the greater it's going to be a thickness is more than, because the minimum is kind of